Hey everyone, welcome to my channel The Real Programmer. Today we are going to discuss some basic concepts of machine learning. I am Kunal and let's jump right in. Today in this video we will be discussing about what is machine learning, why use machine learning, types of machine learning algorithms, components of machine learning and machine learning lifecycle. Let's start with the first topic, what is machine learning? There are many subsets of artificial intelligence like deep learning, natural language processing, convolution neural network, recurrent neural network, speech recognition. In the same way, machine learning is also a subset of artificial intelligence. At its core, machine learning focuses mainly on creating systems that can learn and make decisions without being explicitly programmed. During machine learning, a large amount of data is presented to the machine so that it can be trained in order to make predictions, find patterns, and classify the data. Why should we use machine learning? I will try to explain this with the help of an example. Let's take a simple and historic example of spam filtering. Suppose you have a task to write a spam filter using traditional programming technique. The steps that you might follow would be: first of all, you would collect some samples of typical spam and non spam emails, which is also called ham. Then you will try to find out some patterns by looking at those samples. Suppose that you found some patterns, and suppose that you found that words like lottery winner, credit cards, prize money, win cash are the most common words that appear in most of the spam emails. Next step for you would be to write a detection algorithm for each of the patterns that you found, and your program would flag emails as spam if one or more of the patterns were detected. Next, you would test your program and modify if needed. And finally, if you feel the program is good enough, then you would launch it. Writing a spam filter is a complex task, and you might end up having a long and complex list of rules in your program, which is pretty hard to maintain. On the other hand, a spam filter, which is built based on machine learning, automatically learns the patterns from the samples of the spams and hams which is provided at the time of training, and the program will be able to predict new spam and ham. The program would be simpler and easier to maintain. Suppose you further found that your program is not working as spammers have started using new words or phrases in this spam. Then you will again have to change your program and add new rules, then test your program on older and newer emails. And if you think it is good enough, then deploy it again. Every time the spammers change their words, you will again end up repeating this process and your program will keep growing bigger and complicated. Whereas a spam filter based on machine learning will automatically detect new patterns when flagged by users, and it will start flagging without human intervention. So, machine learning is best suited in solving the complicated problems which cannot be solved by applying a fixed algorithm. Let's look at different types of machine learning. Broadly, machine learning algorithms can be categorized into three main categories: supervised learning, unsupervised learning, and reinforcement learning. Let's talk about them in brief. The supervised learning models are trained using the labeled dataset. The goal of supervised learning is to map input data with the desired output, which is also called target or label. In case of supervised learning, a machine learning algorithm is presented with a set of input data along with the desired output, which is also called label or target. The machine learning algorithm learns the pattern present in the dataset and generates a function which maps input data to the output data. The new state of the machine learning algorithm is stored as a machine learning model. Next, when we provide an unseen data to the model is able to make a prediction. Next, we will talk about unsupervised learning. Here, the machine learning algorithm studies the data to identify patterns without any particular guideline. The main goal of an unsupervised machine learning algorithm is to find the hidden groups within the dataset called cluster. Unlike supervised learning, in case of unsupervised learning, There is no target or label provided with the dataset. Instead, the machine learning determines the correlations and relationships by analyzing available data and divides the dataset into different clusters. Next, let's look at how reinforcement learning works. Reinforcement learning is a way for computers to learn independently by making a series of decisions and learning from the outcomes. Through trial and error, the program determine the best action within a certain context and optimize their performance. In reinforcement learning, the computer program is called an agent, which explores and interacts with the environment. A policy is how the agent behaves at a given point of time based on the current state. Environment is the context in which the agent operates. Then there is a learning algorithm which updates the policy based on the rewards received from the environment as a result of each action. The agent interacts with its environment by producing action. As a result of the action, the state of the agent changes. The agent then receives a positive or negative rewards based on its actions. The learning algorithm analyzes the reward and updates the policy accordingly and gradually learns how to complete a task. Let's quickly look at the components of machine learning. There are three components of a machine learning solution. The first component is the dataset, and it is the most important component of a machine learning solution. The data is collected based on the business problem to be solved, pre-processed, and then explored before it is used for training. Data quality is the most important factor that affects the performance of a machine learning model. The next component is the algorithm. Simply, an algorithm can be considered as a mathematical or logical program that learns the patterns and relationships between features and the target variables. There are different types of algorithms that can be chosen. The selection process is experimental and depends on the problem and also the nature of the data. The next component is the machine learning model. A machine learning model is the final outcome after the algorithm has learned the patterns from the data. The final model can be used to make predictions. In real world, an experiment is conducted using different values of the hyperparameter values of an algorithm, which is then evaluated using different metrics. Ultimately, the best model is chosen and deployed in production. I will explain hyperparameters in a bit detail in the next section. Next, we will discuss the life cycle of machine learning process. First stage of a machine learning life cycle is planning. In this stage, we try to understand the business problem in detail, which will help us to scope the necessary technical solution, identify the data sources, plan on how to evaluate model performance, and more. Next step in the machine learning lifecycle is data pre-processing. It is a very crucial step in the machine learning lifecycle. There are several actions to perform in this step. To name the most important actions, there is data cleaning step, in which we turn the messy raw data into clean, tidy data which is ready for analysis. Then there may be steps like checking for missing values, scaling the column values if required. Another one is the feature engineering, in which these data sets are manipulated to create or remove variables, which is also called features, that improve the model's prediction accuracy. We create or remove the same set of features in both the training set and the testing set. In the end, there is data splitting, in which we randomly divide the records in the data set into a training set and a testing set. For a more reliable assessment of model performance, we generate multiple training and testing sets using cross validation. Next in the life cycle comes the model selection step. Although the name of this step is model selection, but we select the best machine learning algorithm, as the model is something which is produced after training an algorithm. There are many types of models to choose from, including linear regression, decision trees, and neural networks, and many more. Model selection significantly impacts the performance and accuracy of the model. Model selection depends on a variety of factors like problem type, data type, computational resources, and many more. Then comes the model engineering step, in which we try to find out the best set of hyperparameters by performing experiments. This step is called hyperparameter tuning. Hyperparameters in machine learning are the parameters that are explicitly defined by the data scientists to control the learning process. These hyperparameters are used to improve the learning of the model, and their values are set before starting the learning process of the model. We try out different hyperparameters to see which one makes it works best. We keep training the model, make predictions on the test data, and evaluate the model until we find the best hyperparameters that make the model perform the best. The last step of the machine learning lifecycle is model deployment. In this step, we integrate the model into the production system. We keep testing the performance of the model to detect any drift because of the changing data. There are techniques like online learning, where the model incrementally learns on the new data, and batch learning, where the model is trained separately on the complete data, which includes old data and new data. In this way, we keep improving the model. Thanks for watching. I'll see you in the next video. Please share your comments in the comment box, and if you liked the video, please hit the like button and subscribe to the channel. Thank you.